Hey everyone, we're going to prove by the principle of mathematical induction that n cubed plus 2n is a multiple of 3, and that's for all positive integers n. Alright, so the first thing we have to do is show, this is going to be step 1, show that the statement is true for n equals 1. So you plug in 1 into these n's and it should be a multiple of 3. So n cubed plus 2 times 1 equals 3. And 3 is a multiple of 3. So yes, it's true. And that's all you have to do for step 1. But let's just check at n equals 2. If n equals 2, we get 2 cubed plus 2 times 2. So that's going to be 8 plus 4 equals 12, and that is also a multiple of 3. And you can keep going on and on and on, and it will be a multiple of 3. So on mathematical induction, it's always going to be true, but you only have to check for n equals 1 for step 1. So step 2, we have two parts. We're going to assume the statement is true. So assume the statement is true for n equals k. So what that means is you're going to write assume k cubed plus 2k is a multiple of 3. All right. And then you're going to prove, that's A. And then B, we're going to prove that that it's true for n equals k plus 1. So just take this, and everywhere there's a k, put k plus 1. So you're going to do k plus 1 cubed plus 2 times k plus 1. And we want this to be a multiple of 3, so I'll just do that. Now, so from here we have to do our proof. So what I'm going to do is go ahead and expand this. I'm going to do it on the next slide, and I'll write it out again. So what we have is k plus 1 cubed plus 2 times k plus 1. And this is going to be a multiple of 3. We've got to prove that. So I'm going to expand this using the binomial expansion. So for our binomial expansion, this equals k cubed plus 3k squared plus 3k plus 1. You could think of it as your Pascal's triangle, but or you could just write this out 3 times and FOIL it out, but you'll get this. All right, and then just add this term here. This is 2k plus 2. Now, let's simplify this. What I want to do is find this term here. On these kind of problems, find something that looks like this, because we already know this is a multiple of 3. So I've got this term, and I've got this term. So I'm going to write those two together. I have a k cubed plus 2k. All right. And then so I'll put this separate. If you add these, that equals 3. So this is 3k squared plus 3k plus 3. So I have k cubed plus 2k plus, and I'm going to pull out a 3. This is going to be k squared plus k plus 1. Now, we already know that this is a multiple of 3. And we also know that this is a multiple of 3. So this is a multiple of 3. And this is a multiple of 3. And so we can use the assumed statement that a multiple of 3. So I'll put multiple of 3 plus a multiple of 3 is another multiple of 3. It actually helps to write it like this. When we already know this is a multiple of 3. So I can call this part I. I can write this as 3I because I know it's a multiple of 3. It says it is. All right. And then I can call this part J. So this would be plus 3J because we have the 3 in front here. And then I can write this as 3I plus J. So this whole thing is a multiple of 3. And that's it. Thank you. Have a nice day. Bye-bye.